Good morning. I'm glad to be here. I thank the organizers for inviting me. I want to talk to you today about our work in the area of antibiotic-resistant bacteria. And unfortunately, as you probably well know, lots of bacteria are already resistant to antibiotics, and I don't need to remind you about methicillin-resistant Staphylococcus aureus, a very famous case of such an organism which has become resistant to antibiotics. The case of Staph aureus is that it's resistant to beta-lactam antibiotics. These are the most important antibacterial chemotherapeutic agents used in the clinic today. Compounds that are familiar to you, like penicillins and cephalosporins. And many organisms have become resistant to them by virtue of their ability to produce enzymes called beta-lactamases, which modify the structure of the antibiotic and make it non-bactericidal. The most troublesome of the beta-lactamases are metallo-beta-lactamases that require a metal ion at their active site for activity, and these are an emerging, increasingly serious medical and pharmaceutical problem throughout the world. And the reason is that there are no clinically useful inhibitors of the metallo-beta-lactamases. They have a very broad substrate specificity. They're active against all types of beta-lactam antibiotics. And fortunately, what I'm able to tell you is that we have a solution to that problem. This is an increasing problem. There are hundreds of different beta-lactamase enzymes known. There are now over a dozen metallo-beta-lactamases that have been identified, and that number increases each year. So it's anticipated that, as has been true for every other beta-lactamase mediated infection, this problem is going to continue to increase. And so the current budget for market for beta-lactam antibiotics in the U.S. is around $15 billion a year, and we expect that this metallo-beta-lactamase contribution to that is going to be significant, increasingly significant each year. The good news is that we have at Texas Tech University discovered an entirely new class of extremely potent, extremely specific, and highly effective metallo-beta-lactamase inhibitor compounds that are based on nucleic acids. Often these kinds of drugs are called aptamers, nucleic acid aptamers. And we have three categories of drugs: single-stranded, double-stranded DNA, and also RNA, which are extraordinarily effective in inhibiting metallo-beta-lactamases. So the idea is similar to that used for the well-known drug preparation Augmentin, that you combine the inhibitor compound with an antibiotic to take care of antibiotic-resistant bacteria. All of our inhibitor compounds have been studied and shown to inhibit in the same way, even though the sequences of all three categories are very different, and all of our technology is patent protected. Just a little science here to show you that this actually works. We're able, in the case of both gram-positive and gram-negative antibiotic-resistant bacteria, to kill them in combination. This is a petri dish, photograph of a petri dish that contained antibiotic-resistant bacteria. This is a sterile disc that was soaked in the antibiotic Keflex, and obviously it has no effect on the growth of the bacteria. This is a disc that was soaked in our inhibitor compound. Again, no effect, but as you can clearly see here, if you combine the two together, as they diffuse out into the gel, they're actually killing resistant bacteria that are otherwise unaffected by the antibiotic. So the advantages of aptamers are that they are well known to be extraordinarily effective and often very, very precisely specific. There are other companies, of course, listed here that have invested in using aptamers for other therapeutic agent purposes. Our aptamers bind the enzyme, the metallo-beta-lactamase, at or near the active site, certainly in a way so as to influence the metal ion binding. Aptamers are well known to be non-toxic, non-allergenic, and their synthesis is an automated, commercially available, relatively inexpensive process. Our ongoing work is to include expanded pathogen efficacy studies and also some preclinical efficacy trials in an animal model of a bacterial infection. We also need to do some preclinical toxicity trials in an animal model. What we're offering is a chance to partner with other companies in order to complete the preclinical trials we need. We offer our technology for licensing. The licensees will have an opportunity to get an early jump on a very serious medical and pharmaceutical problem based on a proven strategy. And if you need more information, you can visit us in booths 703 and 705. Thank you.